Hi everyone, in this segment we are going to be talking about the effects of inductive electron donating groups on acid and base strength. Check this out. When it comes to inductive electron donation, we are going to see that it will decrease acid strength. It decreases acidity. What inductive donation does is it stabilizes the acid form, but it destabilizes the conjugate base. Okay, that's important. This is, again, the flip side of inductive withdrawal. To reiterate, electron withdrawal via induction destabilized the acid, and it stabilized the conjugate base. This is the flip side. Now we are going to stabilize the acid with inductive donation and destabilize the conjugate base. Okay. Now, in my experience, the inductive donation effect is a more subtle one and harder to pick up. So let's talk about this. What you're looking at here is an example between three alcohols. We have methanol, we have ethanol, and we have tert-butanol. And notice their difference in pKa value. It's not a huge substantial difference, but there is a difference in pKa values. Okay? And the difference is due to inductive donation. It is the case that alkyl groups, specifically carbon-hydrogen groups that are sp3, will be inductively donating. So you can consider each of those carbon atoms to have electrons around it, as well as electrons around the hydrogens that are bonded to those carbons. These groups will inductively donate towards the oxygen atom. That inductive donation is going to increase if we have more alkyl density. With greater alkyl density, there is a greater inductive donating effect. In methanol, there is only one alkyl group. In ethanol, there is two carbons, okay, one total alkyl group, but two carbons, and therefore there is more alkyl density. There is a greater inductive donating effect. In tert-butanol, you have 1, 2, 3, 4 carbons. Each of them possess electron clouds. There is now going to be a greater inductive donation. And let's now look at the conjugate bases. So we've said inductive donation decreases acidity. What is it doing to the conjugate base? We are going to deprotonate each of our alcohols. We have our three alk oxides. The one that is the weakest base is the one far to the right, okay, on the far right. That is the weakest base, the least basic species, because there is the least amount of electron donation via this inductive donation. What will happen is if there is more inductive donation, as is the case with that tert-butyl group in the conjugate base of tert-butanol, that will concentrate the negative charge on the oxygen. So you would say that alkyl density is concentrating the negative charge on the oxygen. This alkyl density is also acting to concentrate, Ryan, is acting to concentrate the negative on the oxygen. However, it's not going to be as concentrated as the negative charge on this oxygen. So let's even use the darkness of the blue to represent how concentrated the negative charge is. In this structure, we have a concentrated negative. Here, it's less concentrated. And in the far right structure, there's only one alkyl group acting to inductively donate. So there is less concentration of the negative on the oxygen. Okay? That is essentially what you're looking at. We see decreasing acidity going in this way, right? Decreasing acidity with increasing inductive donation towards your group. And so it is the case, that you have increasing carbon chain length or increasing carbon chain substitution. Being closer to the acidic hydrogen means there will be lower acidity to that hydrogen, okay? Again, this is a more subtle form of effect on acid and base strength. I do want to give you another example of this. Let's say you had, let's take this example. We're going to have a silicon atom. So silicon on the periodic table is right below carbon, okay? Right below carbon. And we're going to have these two carboxylic acids. The one that is less acidic is the one with the silicon. This is a less acidic species. This is going to be a more acidic species. Because on the periodic table, silicon is below carbon, okay, in the same column. Silicon is less electronegative. If it is less electronegative, that means ultimately there is more donation. It is actually donating towards the carbon, which allows then the carbon to inductively donate even more towards the carbonyl, that C double bond O. Yes, there is some inductive donation by this alkyl group, but ultimately the inductive donation in the bottom example is not as pronounced as the inductive donation here because the silicon atom is less electronegative. It is more donating via this inductive donation. Now, another kind of nuanced example that I want to show you is this idea of just having an alkyl chain, which is say an ethyl group, versus having a carbon-carbon double bond here. Okay. Now, what's interesting, and this isn't intuitive, is this one is the more acidic species. This one is the less acidic species. And the difference in acidity is due to inductive effects. Specifically here, in the top example, you have an sp3 alkyl group. It will inductively donate. So we're going to say inductively donates. Down here, what's interesting is when you look at the conjugate base, if anything, what is happening is this sp2 carbon group is functioning to withdraw just a little bit, ever so slightly, or rather we could say that it is just not donating to the same extent that this would donate. Now that is a little counterintuitive, right? We almost want to think about this maybe resonating. But the idea is in this carboxylate ion, the negative charge itself is resonating, and that resonance back and forth is so effective that it doesn't enable this pi bond to resonate over the carbonyl. And thus, instead, it just is not donating, and if anything, it might try to tug a little bit. Whereas in the top example, this will inductively donate both in the acid form and in the conjugate base. The alkyl group will also inductively donate in the conjugate base, making this compound ultimately less acidic and this more acidic. So remember, electron donation decreases acid strength, whether that's resonance or an inductive effect. Alkyl groups have the ability to inductively donate, assuming that is an sp3 hydrocarbon chain. Silicon is less electronegative than carbon and would be more electron donating, and again, that was a sigma electron donation.